Hello there, science classes. Mr. Zana here with another Edpuzzle Slides. Today, we are going to continue with Unit 3, investigating force and motion. We're on to Newton's third law. First law, inertia, was miskanopic. The second law I covered was force. And now we're on the third law for Newton, and it is going to be equal and opposite reactions. So, we're going to watch a quick, short video on Newton's third law.
Topic: Newton's third law of motion. Why does a swimmer push the water backward? Oh no, there's a hole in the boat. Now, how will you reach the shore? Don't worry, do as I say. Jump in the water and push the water backward with your hands. This will help you to move forward towards the shore. No, you are not pushing the water backward. See, you are moving forward towards the shore. Do you know why you were able to move forward by pushing the water backward? To understand this, you need to learn about Newton's third law of motion.
Hooray!
Newton's third law of motion states that, for every action, there is an equal and opposite reaction. Nah, not that action. Wait, let me explain. When we swim, we apply force and push the water backward with the help of our hands. This is action. In response to this action, the water pushes us forward with an equal force. This is reaction. Thus, in order to move forward and swim, the swimmer pushes the water backward.
Well, as promised, a short video. So, let's continue looking at our Newton's third law, okay? So, our cue, today we're going to learn about Newton's third law, equal and opposite reactions, and show how it's a part of everyday life. How? Well, we're going to do an Edpuzzle and also a Google form, which, as you know by now, is our warm-up form that you should have done before we started this Edpuzzle. Why? Well, this is going to help us understand forces and on how they operate and react to one another. So we were talking about acceleration in the second law, Newton's second law. Well, acceleration also is part of our third law, okay? So if I'm accelerating in one direction, I'm putting an equal and opposite force on something else, as we'll see as we're going through this, all right? So, Newton's third law, equal and opposite Edpuzzle. Here is the chance for the Edpuzzle. As usual, voices off when the presentation is occurring. Please raise your hand if you have any technical difficulties or issues, and either myself or Ms. Kanopic, depending on the class you're in, will take care of it for you or at least help you out. Watch and have some fun. Please stay seated, and then watch and be prepared for your exit ticket at the end of the slides, all right? We do all of this, and we will be successful in learning about Newton's third law, equal and opposite reactions, all right? So, as usual, still, we're in Unit 3. Here's the unit organizer. You'll see the arrow is still pointing at Newton's laws. We're on Newton's law 3 now. You'll see the other arrow is pointing that we are still on track with where we want to be. And by now, we should be able to answer almost all of our vocabulary words, essential vocabulary words, and also the 4 questions at the bottom of the first page of our unit organizer. You should be keeping up with this in your ISNs. Second page of the unit organizer, again, we're on Law 3. We should already have Law 1 and 2 filled out. We should have speed, velocity, and acceleration filled out on the right-hand side. So at this point, we're almost done filling out our unit organizer in our ISN. So Newton's third law of motion specifically states that for every action, there's an equal and opposite reaction. These can also be expressed as action-reaction forces. An example is me walking on my feet. So my feet are pushing down on the floor and the floor is pushing back up on my feet. That is an action-reaction force. My feet pushing down is the action force. The reaction force is the floor pushing back up on it. All right? We're going to be doing a bunch of these. So next one, a football lineman pushing against each other. Active force, well, usually the defensive lineman is trying to get to the quarterback, so he's pushing on the offensive lineman's shoulder pads. So the reactive force is the offensive lineman's shoulder pads, and the action force is the defensive lineman's hands on those pads. All right? So the action force is usually the one that's initiating that contact or that force, and the reaction force will be the one that's being pushed upon. How about this one? A vehicle tire. Active force is the air in the tire pushing, trying to get out of the tire, and the reactive force is the tire pushing back on the air. How about this one? It's an interesting one. Two people holding hands. This one is interesting because it depends on the point of view. So each person that's holding the other person's hand will believe or perceive that they are the active force and the other person is the reactive force. So that's an unusual one. So this one is determinant on the point of view. So now we're going to get into some that you're going to answer for us, okay? So our first one, a hammer pounding a nail. Which force is the hammer? Is it the active action or reaction force? Which force is the hammer? All right, our next one. A baseball bat hitting a baseball. Which force is the baseball? Action, reaction. Here's a good one. Example of an arrow striking a target. The arrow is which force? Action or reaction? If I'm standing in the rain is which force? I'm standing in the rain, and the rain is which force? Action or reaction? All right. How about I put WWF. Well, it's WWE. Wrestlers headbutting each other. Who is the action force? Two wrestlers headbutting each other. Which one is the action force? How about in a car crash where a car is rear-ended sitting at a stop sign? What force is the car that was stopped at the stop sign? Two cars, the one being hit that's stopped at a stop sign. Which one is he? The action or reaction force? How about a balloon filled with helium? The helium is which force? How about of a little girl kissing a boy on the cheek? Which force is the girl? All right. Well, we're getting down to it now. Here's your review. Today we looked at Newton's third law, equal and opposite reactions, and how you can recognize it in our everyday lives. We did an Edpuzzle to practice equal and opposite reactions. We also completed our warm-up. Hopefully by now you have completed your warm-up questions. Why? Well, this is going to help us understand how forces act upon one another. So, exit ticket time. Here's your exit ticket. Me sitting in my desk chair is an example of equal and opposite reaction forces. Which force am I in this example? Am I the action or am I the reaction force? All right, thank you so much for paying attention today, doing this Edpuzzle. Hopefully you all got great scores on it. Until next time, please make sure you're updating your ISNs. Make sure you're reviewing these slides and the Edpuzzles, because we do have an exam coming up on November 12th or 13th, depending on if you're on A or B schedule. See you next time.